Okay, the next problem I'm going to look at that I was asked about is this one. F of x is this polynomial. X is larger than negative 1.5. Find the derivative of the inverse function when y is 7. So that problem is a lot like example 2 here in the notes. So you might want to take a look at this to, you know, make sure it makes sense to you, and then the other problems as well. So I'll just say that up front. So to solve this problem then, what we're trying to do, we're going to use the same result, by the way. We're using this result in the red box. So, okay, so to find the derivative of this inverse function, what we're going to do is, according to the result in the red box, that's equal to f inverse, f inverse prime at, say, y equal to 7 is going to be equal to 1 over f prime of a, where a has the property that f of a is equal to 7. So we want to know that value of x, which we're calling a at this point, that maps into 7 under f. And when we find that, then all we need to do is take the derivative of f, the f that's given, 1 over that, and then evaluate it at this, at this particular value a. Now, one thing I did want to mention is, this function, we're interested in this function when x is larger than or equal to negative 1. So if you take a look at this function, I mean, I guess this is a parabola. The graph of this is a parabola. So if you take a look, this function, it's not going to have an inverse over its whole domain because it's not a one-to-one function. Like if you take, say, x equal to, 5, or excuse me, y equal to 5, there's two different x values that map into y equal to 5. So, if you were looking for an inverse function, then 5 would have to map to two different x values, and that violates the definition of a function. So this function doesn't have an inverse over its whole domain. That's why this is restricted to just, it doesn't have to be x greater than negative 1.5, but you do need to restrict the domain so that the function's one-to-one so that the inverse would exist. So that's one thing to note. All right, but having said that, what we do need to do is figure out where that value of x that maps into 7. So if we're trying to solve that problem, then that's the same. I'm moving around here, I see. That's the same as solving the problem, say, x squared plus 3x plus 1 equal to 7. So that's a pre-calculus problem. It's actually an algebra problem. So to solve that, you want to, subtract 7 from both sides, because you can solve, it would be a quadratic equation. So subtracting 7 from both sides, you'd have x squared plus 3x minus 6 equal to 0. And then using, is this factorable? I don't think so. So using the quadratic formula, x would be equal to minus, the quadratic formula, ax squared plus bx plus c equal to 0 has solutions x equal to minus b plus or minus square root b squared minus 4ac all over 2a. So we're using that. So x would be equal to minus 3 plus or minus the square root of b squared, which is 9, minus 4 times a times c, all over 2. So x here is negative 3 plus or minus, that's going to be the square root of 33 over 2. Now, one of these is positive and one of these is negative. We need x to be larger than negative 1.5. So because of that condition, we're going to choose x equal to negative 3 plus the square root of 33 over 2. Okay, so that's our value. That's the value of a that we're going to use. So if we use that value of a, then f inverse prime at y equal to 7 is going to be 1 over f prime at that value at negative 3 plus the square root of 33 over 2. And so what's that? Well, f prime of x is 2x plus 3. And evaluate that at negative 3 plus the square root of 33 over 2 is going to be 2 times negative 3 plus the square root of 33 over 2 plus 3, which is going to be square root of 33, which is not a perfect square. It's going to be an irrational number. So that means what we have here will just be 1 over the square root of 33. So that's it for this problem. Any questions? Let me know.